Page 72, Dark Matter, Section 1. Years ago, when my daughter was a toddler, she performed a fascinating experiment from her booster seat. As I watched, she carefully dropped nearly 2 dozen overcooked peas from her dinner plate. She let them go one at a time, and not a single pea disobeyed the universal law of gravity. Each one fell directly to the floor. Gravity is a marvelous force, but a troubling one. Newton and Einstein explain how gravity affects the matter in the cosmos. Overcooked peas, ripe apples, people, planets, giant stars, their ideas apply to all matter that we can see, touch, feel, smell, and occasionally taste. And according to Newton and Einstein, most of the matter in the universe appears to be missing. I don't mean missing in the sense of a lost sock. Pause there. I just read section 1. Fill in your key idea. Section 2. By watching certain stars and galaxies, astrophysicists can measure the power of gravity in the distant parts of the cosmos. Typically, if gravity is strong, we can see a large object or objects nearby. The effect of a giant round star or a black hole will be enormous, for example. The gravity around a tiny space rock drifting through the cosmos, not so much. For years, astrophysicists have been tracking the incredibly powerful gravitational fields without enough visible mass to create that power. Something has to be there, generating all that gravity. But we don't see the stuff. Whatever is there doesn't interact with our matter or energy. We've now been waiting nearly a century for someone to tell us why most of the gravity we've measured in the universe, about 85% of it, is tied to some kind of material we can't detect. We are essentially clueless. I just read section 2. Pause the video to write your key idea. Section 3. This is a major scientific riddle, and we find ourselves no closer to an answer today than when this missing mass problem was first uncovered in 1937. At the time, the Swiss-American astrophysicist Fritz Zwicky was studying the movement of galaxies within a huge region called the Coma Cluster. This cosmic neighborhood lies very far from Earth. A beam of light leaving the Coma Cluster has to speed across the universe for 300 million years to reach our telescopes. The Coma Cluster appears delightfully crowded from a distance. 1,000 galaxies orbit around its center, moving in all directions like bees swarming a beehive. Gravity holds the cluster together, preventing anything inside from drifting away. Zwicky measured the strength of this gravitational field by watching a few dozen of the galaxies inside, but something wasn't right. There was too much gravity. So he added up the mass of all the galaxies inside. Even though the Coma ranks among the largest and most massive clusters in the universe, the sum total was not enough to crank out the kind of gravity that would hold all of these galaxies in place. Something else was there, something he could not see. I just finished reading section 3. Pause the video to write your key idea. Section 4, page 75. After Zwicky, astrophysicists have discovered other galaxy clusters with the same problem. This missing mass remains the longest standing unsolved mystery in astrophysics. Today, we've settled on a term for the stuff: dark matter. I just finished reading section 4. Write your key idea. Pause the video. Section 5. As a kid, I lived in one of 2 matching apartment houses. My close friend, a classmate in elementary school, lived in the other building. Thanks to him, I learned how to play chess and poker and the board games Risk and Monopoly. More importantly, he taught me how to really use binoculars, to point them to the moon and the stars. As I switched my binoculars to telescopes and moved across the rooftop of my building to clear views from the desert or from the open sea, I fell in love with all the amazing sights scattered across the night sky. Yet astrophysics isn't just about what we see. It also deals with what we don't see. Fritz Zwicky found evidence for matter that he could not see within clusters or groups of galaxies. Years later, in 1976, Vera Rubin, an astrophysicist at the Carnegie Institute for Science in Washington, discovered the missing mass hiding within the galaxies themselves. She was studying spiral galaxies, flat, disc-shaped collection of stars with a bright bulge in the center and several star-packed arms twisting outward. Rubin tracked how fast the stars race around the spiral galaxy centers. At first, she found what she expected. The stars further from the center, held tight by gravity, moved at a greater speed than the stars close in. Yet Rubin also watched the areas beyond this disk. A few bright stars and lonely gas clouds lingered out there. Since there was little visible matter between the objects and the edges of the disk, nothing was holding them tight to the rest of the rotating galaxy. Their speed should have been falling with increasing distance out there in Nowheresville. But for some reason, their speeds, in fact, remained high. Rubin correctly reasoned that a form of dark matter must lie in these far out regions, holding on to those distant objects, hiding well beyond the visible edge of each spiral galaxy. Thanks to Rubin's work, we now call these mysterious zones dark matter halos. I just finished reading section 5. Pause the video to write your key idea. Section 6. I'm on page 77. This halo problem exists under our noses right here in the Milky Way. From galaxy to galaxy and cluster to cluster, the difference between the combined mass of all the stuff we see and the amount of mass that should have been there based on gravity's strength is enormous. Cosmic matter has about 6 times the total gravity of all visible matter. Or, to put it another way, there is 6 times as much dark matter as normal matter. So what is dark matter? I'm on page 78, still section 6. So what is dark matter? We know it cannot be made of ordinary matter, like protons, neutrons, and the rest. We've also ruled out black holes and other cosmic oddities. Could the dark matter just be asteroids and comets? Planets wandering through space, untied to a solar system? They all have mass, but none of them produce any light of their own. They would appear dark to our detectors. In that sense, they fit. But there would not be enough of them, so we have to rule out wandering planets. We also know that dark matter can't be made up of the same particles as planets or humans or hamburgers because it doesn't seem to follow the same rules. The forces that bind the particles in our world together don't apply to dark matter. The only rule dark matter seems to follow is gravity. Maybe there's nothing the matter with matter, and that it's gravity we don't understand. Maybe Newton was wrong, Einstein too. Maybe you, the reader, will eventually discover while cruising past an apple orchard on your self-driving robotic car how gravity really works. In the meantime, we have to work with the facts that we have now. And as best as we can figure, dark matter isn't just matter that happens to be dark. Instead, it's something else altogether. I just finished reading section 6. Write your key idea.